Example 10. A submersible that is exploring the ocean floor begins to ascend to the surface. Now, I'm going to stop right there. First of all, if we're talking about a submersible, another way we can think about that, I'm not used to hearing the word submersible, but I'm going to compare that to a submarine. It's exploring the ocean floor and begins to ascend. What the heck does ascend mean? It means go up. So we have a submarine, the bottom of the ocean, it's starting to go up to the surface of the water. Now I'm going to keep reading. The elevation h in feet, elevation means like how deep it is, okay, of the submarine is modeled by the function h of t equals 650 t minus 1300, where t is the time in minutes since the submersible or submarine began to ascend or go up. Now it says letter A, we want to graph the function and identify the domain and range. If we're going to graph the function, in order to do this, I'm first going to make a chart. Typically we have x and y, but if we take a look at our function, we don't have x and y because this is in function notation. So instead of an x, we're using a t, which is representing our time, and instead of a y, we have an h of t, which is representing our y. Now, it says where t is the time in minutes since the submersible began to ascend. Well, think about this, people. If we're at the bottom of the floor and we start our clock watch or our stopwatch and we start going up to the surface, at what time is the starting time? Well, that's at time 0. T is the time in minutes, so then we're probably going to look at like after maybe 1 minute, 2 minutes, 3 minutes, etc. But if I look at my graph over here, I really don't want to list all of those minutes if I don't have to. So my graph is going by 4, 8, 12, 16, 20. So maybe I want to figure out, well, where is my submarine after 4 minutes? Where is my submarine after 8 minutes? Where is my submarine after 12, after 16, after 20? We'll just see where we're at. If we have to go further, we can do that. Then I'm going to take my function, 650t minus 1300. So 650t, which I'm substituting 0, minus 1300. If I multiply this to 0, I'm going to get negative 1300, which tells me that when I started, oh, that's not 1300, that's 13,000, that my submarine was actually down here at 13,000 feet below the surface level. So now that I'm looking at this, I'm going to label my graph. This is representing time in minutes. And then this is representing elevation in feet. So my submarine is 13,000 feet below the surface of the water. Now, after 4 minutes, so 650 times 4 minus 13,000, which I should go put another 0 on there, sorry, is negative 10,400, which gives me the point over 4 down 10,400. So I don't know, maybe like right there. We're just going to guesstimate it a little bit. Next one, 650 times 8 minus 13,000 is negative 7,800. So after 8 minutes, we are down negative 7,800. $650 times 12 minus 13,000 is negative 5,200. So we've got over 12 down negative 5,200. Then we're going to have 650 times 16 minus 13,000 And I just need to grab my calculator for this one. So 650 times 16 minus 13,000 is negative 2,600. So about maybe right there. And then 650 times 20 minus 13,000 equals 0. Now, I know that this graph actually stops. This is a very helpful graph for you, but the question is, should we go to 24? Should we do this again? And the answer is no, because if we're talking about a submarine doesn't come up to the surface of the water and then take off and start flying, okay? The highest that the submarine can go is the surface of the water, which is right here. So once it reaches the surface of the water, it can just keep floating along the surface of the water, but we just wanted to know how long did it take to get there. Now, part A, graph the function and identify the domain and range. First of all, if we're going to finish graphing it, we're going to take a nice line and we're going to connect it. This line should not have arrows on it because of what we just discussed. Okay, it started down here at negative 1300. That's as low as it went. So we're not going to put an arrow on that and keep going lower. Just like we're not going to put an arrow on this and keep flying into the sky. A submarine does not do that. Then it says to identify the domain and range. Well, keep in mind the domain is all the x values. In this case, it's all the t values. And the range is going to be all your feet or all your y values, which in this case is your h of t. So our domain is anything from the left to the right. So if I follow my graph to the left and I'm looking at my x values or my time started at 0 and went to 20. So 0 to 20. Now I'm going to use a bracket because I actually touched the 0, and I'm going to use a bracket because I actually touched the 20. My range is my dependent variable, which is all of my y values, which is how low the submarine went to how high the submarine went. Well, the submarine started down at negative 13,000 feet and went up to the surface, which was 0 feet below the water. Again, I'm going to use a bracket because it was actually there. It didn't get close. And I'm going to use a bracket on the 0 because it actually got to the surface. Now, letter B, and I realize you can't actually read this because I wrote over it, but it says interpret the slope and the intercepts of the graph. So, the slope, we can use any 2 points, but we actually don't need it because I'm going to go back up here, and we have y equals mx plus b. So my slope is actually given to me right here, which is 650. So for part B, m equals 650, and then we have to actually interpret that at what is going on. So if we look at our graph, over here we have feet. Over here, we have time. So we're rising 650 feet, 650 feet, 650 feet, 650 feet every minute. So this is 650 feet per minute, which means the submarine is rising to the surface at 650 feet every minute. Now, the y-intercept is at 0, negative 13,000. And my interpretation there would be that the submarine starts 13,000 feet below the surface. So before it does anything, it's down here at negative 13,000 feet, and that's where it starts its ascent. Your x-intercept is at 20, 0. And my interpretation there would be, well, it takes the submarine 20 minutes to reach the surface, because this is in minutes. So this is in feet, this is in minutes. So it takes the submarine 20 minutes to reach the surface of the water.